Hello, Hornets. Welcome. Today we are going to be starting section 9.2. We're going to be taking a look at series and their convergence. And in this video, what I hope to just start you on is the pathway for our flowchart. And as we begin, what we need to remember is that we are talking about monotonic sequences, okay? Or in this case, a monotonic sequence that's added together. And since monotonic sequences are sequences that have values that always approach a single term, it means that you're adding less and less and less each time. Now, in order for this to happen, our summation that we are working with, and we're going to start at n equals 1 and go to infinity, we're going to call it a sub n. This series, once again, it's a series because it's a summation now, is going to have to approach 0 for the limit, specifically the rule. The limit as n approaches infinity for a sub n must approach 0 in order for us to have monotonicity. Now, this is the first basic concept that we saw, and this is what we have to start with. Because if we don't have values that get smaller as the series goes on, then we end up diverging and adding more and more and more and more. So our first test is called the nth term test. And this is the fundamental basis that we begin with. All of the terms of the series for the rule a sub n have to approach 0. And if this doesn't happen, then we automatically have convergence. So this is called the nth term test, and we can look at it in many different forms. For example, if I'm looking at the summation as n begins at 1 and goes to infinity of 1 over n. Now we know this is the harmonic series, and we know the harmonic series as an integration is going to diverge. We saw that when we were working with our improper integrals. But what's interesting here is that we're now only going from 1 to infinity. Unlike the integration, where we could go from 1 to 0, that's no longer an option. So you have to understand we're now not talking about improper integrals. We're talking about series. And so when you start this road, remember, it's series that we work with. So if I look at this, you'll notice I'm going to start off and ask, is the limit as n approaches infinity for 1 over n equal to 0? And it's a yes or it's a no. We can use Feppel, we can use L'Hopital's rule, we can use whatever facilitates this action. And this is our first step that we will always apply. Now, just because it works doesn't necessarily mean that we have a convergence. It simply means that we've satisfied the first step where convergence has to happen. All right, and then we have to now check for other rules. So this was the nth term test. Thank you very much. I hope it helps. And please remember, it is the first test you always use. Does the limit as n approaches infinity for the rule a sub n equals 0? Yes or no? If it's a yes, convergence might occur, and we now need to do more steps. If it's a no, we stop with divergence, and we now know that the series would then diverge. Thank you very much, Hornets. Please be well, take care, and thank you very much. If I can stop this, I will.